Today let us discuss on LANDSAT program. See, especially in the field of remote sensing, we are making use of the satellites to collect the required information about the Earth's surfaces, of which LANDSAT was the first satellite launched by NASA of USA in the year 1972 to gather the required information of the Earth's surface features. During that time, that satellite was called as Earth Resources Technological Satellite, ERTS. That satellite carried return beam Vedicon and multispectral scanners. Return beam Vedicon was collecting the data in 3 different spectral bands, and multispectral scanner used to collect the data in 4 different spectral bands. So totally we were getting 7 bands of data. The subsequent satellites in the ERTS series were launched during 1975 and 78 respectively, and they also carried similar kind of sensors, RBV and multispectral scanner. And later the same satellite was renamed as LANDSAT program, and in this series about 8 to 9 satellites have been launched so far. So LANDSAT 4 onwards, they removed return beam Vedicon and they added one more advanced sensor called thematic mapper. So LANDSAT was collecting the data, LANDSAT 4 was collecting the data in 4 bands of multispectral scanner and 7 bands of thematic mapper. MSS used to collect the data in 4 different spectral bands, 0.5 to 0.6, that is the green region of the spectrum, 0.6 to 0.7 red region of the spectrum. Then there were 2 near infrared bands, and its resolution, spatial resolution, was 80 meter, and the spectral resolution were 4 spectral bands. So in a similar way, thematic mapper was collecting the data in 7 different spectral bands. There were 3 in the visible region, 1 in the near infrared, 2 in the shortwave infrared, and 1 in the thermal region of the spectrum. And thematic mapper was a highly advanced multispectral scanner, incorporated number of improvements over LANDSAT MSS. In the sense, MSS multispectral scanner used to collect the data in 4 different spectral bands, whereas thematic mapper used to collect the data in 7 different spectral bands. There was a thermal band also. It was collecting the data with 120 meter spatial resolution. So normally in thermal remote sensing, we are measuring the thermally emitted radiation. So the Earth's surface features emit the electromagnetic radiation at longer wavelengths. That data is being recorded by thermal sensors. Normally thermal sensor data is used to measure the land surface temperature, sea surface temperature, like that. So LANDSAT 4 onwards, we have launched few more satellites, LANDSAT 5, LANDSAT 6, 7, 8, 9, like that. 9 is going to launch in another few years of time. LANDSAT 5 was the longest. It worked even for about 30 years. When it was launched during 1984, nobody expected that it will work for 30 years. It worked till 2013, and in the subsequent satellites, see, they added an advanced sensor called ETM, enhanced thematic mapper, and enhanced thematic mapper used to collect the data with 15 meter spatial resolution in the panchromatic mode. Panchromatic means it is a black and white imagery. So you have 7 spectral bands in the case of thematic mapper. So 7 spectral bands can be used for number of applications. Whenever we talk about a satellite data, each band has its own significance, in the sense they are collecting the data at a different wavelength of the electromagnetic spectrum, and we know the fact that surface features will behave differently at a different wavelength of the electromagnetic spectrum, and using these 7 bands we will be able to identify different surface features in a better way. So the resolution also got improved, the spatial resolution, the spectral resolution, the temporal resolution, and radiometric resolution we talk about when we are considering the satellites. Before going to make use of any satellite data, we must have the knowledge of these 4 kinds of resolution. So this thematic mapper provided 7 spectral bands of data with 30 meter spatial resolution for non-thermal bands, and for thermal band the spatial resolution was about 120 meter. So 30 meter is really an improvement over LANDSAT MSS. So even we will be able to identify 30 meter by 30 meter object. So that is the advantage of thematic mapper. And enhanced thematic mapper collected the data in 15 meter with 15 meter spatial resolution. So that particular satellite, I said, LANDSAT 5, worked for nearly 30 years and it created a Guinness World Record also. So satellites are normally used for number of applications. So even the LANDSAT satellite data are available free of cost. If one wants to make use of any LANDSAT satellite data, he has to visit United States Geological Survey website and it is freely available. And you can make use of this 30 meter spatial resolution, and you can go for 7 different spectral bands, and LANDSAT 8 provided 11 spectral bands of data, 2 thermal bands of data. See, when I say remote sensing, see, it is normally we are collecting the reflected or emitted energy, and this particular satellite is capable of recording not only the reflected energy, it is also collecting the thermally emitted radiation. So that means the surface features absorbs the electromagnetic radiation. This absorbed radiation will be emitted back after some time. So this will provide you the required information about the temperature data and the land surface temperature, subterranean lava channel. If any country is conducting the nuclear test, there will be a temperature difference. And if any industry is discharging the effluents to the nearby stream without proper treatment, and forest fires, see, like that. See, thermal remote sensing is also having wider applications like optical remote sensors. When we talk about optical remote sensing, it means it is the visible plus the reflected infrared region of the spectrum, 400 to almost 3 micrometer, 0.4 to 3 micrometer range, or 400 to 3000 nanometer. In that we will be collecting the data. Beyond that, it may be 8 to 14 micrometer range. So at that wavelength, Earth emits maximum radiation. So that is called as thermal energy. So this particular satellite, LANDSAT series of satellites, is functioning since 1972. So almost it has completed 28 plus 19, 47 years of service, and it is providing enormous data. If anybody wants to make use of any type of data in the visible region, near infrared region, thermal infrared region of the spectrum, they can visit USGS website and they can download the required information. And normally remotely sensed data can be used for number of applications. See, for example, the land surface temperature, the sea surface temperature. And in the case of land surface temperature, based on that, we will be able to say where the temperature is increasing. We are creating more and more impervious layers. Because of that, see, the concrete buildings we are creating, we are cutting the forest. Due to this reason, the temperature is increasing. The temperature can be monitored with the help of thermal sensors. In a similar way, the thematic mapper band 6 is a thermal band which can record the sea surface temperature. And if you have the sea surface temperature plus the ocean color information, normally some of the other satellites are measuring the ocean color. In fact, even in the case of thematic mapper, it is having non-thermal bands. They are capable of measuring the ocean color. Wherever you are getting the green color, especially in the open ocean, you can say the chlorophyll concentration is more. And if you integrate the ocean color with the thermal data, that is the temperature data, sea surface temperature, you will be able to generate a potential fishing zone map, and with that you can direct the fishermen where to go for fish catching and all. In a similar way, Indian remote sensing satellites, we are collecting the data using Indian remote sensing satellites. We have a satellite called OceanSat which records the ocean color information, and if we integrate the sea surface temperature with this ocean color, again we too can map the potential fishing zones and we can direct the fishermen where to go for fish catching and all. So when we talk about satellites are having a lot of applications. It can be used for number of applications, starting from geology, oceanography, then mineral resources mapping, forest resources mapping, agricultural resources mapping, different kinds of land use, land cover maps can be generated based on remotely sensed data. So there are a number of applications. So added to that, if we integrate these spatial data, whatever the data we are getting from the satellites, that can be used to generate the spatial information. And if we want to integrate these spatial data with the attribute data, non-spatial data, then we will be able to generate very useful geographical information system pertaining to a particular area on different themes. For example, a forest resource map, if we want to generate, yes, different kinds of forest resources information can be gathered through satellites. Then secondary data can be collected based on the field work. Then if you integrate both these spatial and non-spatial data, yes, definitely you will be able to generate a very useful forest resources information system. So there are a number of satellites orbiting over the globe, of which LANDSAT satellite is one of the important satellite, and it is still continuing. That program is still continuing, and we must feel proud for these type of satellites, because that was the first satellite dedicated for remote sensing purposes, and still it is continuing. So thank you for your kind cooperation.